Hi, this video is for Monday, April 6th for calculus. We're going to start talking about sequences. So I'm sure you've seen sequences before. They are a list of numbers that typically have a pattern to them. And that could be you're adding the same thing each time, or you're multiplying by the same thing each time, or you could be doing a combination of those things, or subtracting, dividing. As long as there's a pattern, that's what a sequence is. Okay, so in a sequence, the first term is represented by a with a subscript of 1. So first term is a1, second term is a2, third term is a3, and that keeps going. And generically the nth term, so nth term, is a with a subscript of n. And the one after that would be a with a subscript of n plus 1. Okay, so an entire sequence in your calculus book is represented by this notation. So that means an entire sequence that they're calling a sub n. Okay. So we are now going to get started with example 1. We're going to list terms in a sequence. So they're going to give us the formula, and we're going to plug in the numbers 1, 2, 3 to find the first, second, and third term. Alright, so example 1, listing the terms of a sequence. So part A says, list the terms of the sequence an, which equals 3 plus negative 1 to the nth power. Okay, so first we're going to plug in a 1 to find the first term. So we have 3 plus negative 1 to the first. So negative 1 to the first is just negative 1. So we have 3 plus negative 1, which is 2. So a1 equals 2. Okay, now we're going to plug in 2 for n up here. So we're going to have 3 plus negative 1 squared. So negative 1 squared is positive 1. So we're going to have 3 plus 1, which is 4. So a2 equals 4. Okay, so now we're going to plug in 3, so I'm going to write it down here. 3 plus negative 1 to the third power. So anytime you're taking negative 1 to a power, it's going to alternate between negative 1 for the odd powers and positive 1 for the even powers. So since 3 is an odd, this is going to end up being 3 plus negative 1. Okay, and 3 plus negative 1 was 2, so a3 is 2. Okay, and then if you want to list all those out in its sequence, it'd be like this. 2, 4, 2, dot, 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 and you do the dots to symbolize that it keeps going. Okay, so that's it. That's the first problem. You take the formula that they give you and you plug in the numbers 1, 2, and 3 for n, and you find the first 3 terms of the sequence. Okay, so now we're going to try something that is a little more funky. It's got a fraction. Alright, so now our sequence is n divided by 1 minus 2n. Okay, so a1, we're going to have 1 divided by 1 minus 2 times 1. So I plugged in 1 everywhere I saw an n. And now I'm going to simplify. So the top's going to stay 1. 1 minus 2. So that equals 1 over negative 1, which is negative 1. So a1 is negative 1. Okay, now we're going to plug in 2. So now we're going to do A2. So we're going to have 2 over 1 minus 2 times 2. So 2 over 1 minus 4 is negative 3. So A2 is negative 2/3. Alright, and then the third one, A3, we have 3 over 1 minus 2 times 3. So 3 over 1 minus 6 is 5, negative 5. So 1 minus 6 is negative 5. So our A3 is going to be negative 3/5. Like that. Okay, so those are the first 3 terms of this sequence, and if you wanted to write them in order, it would be like this. Negative 1, negative 2/3, negative 3/5, dot, dot, dot. Okay, so that's example 1. Now I'm going to teach you about recursively defined sequence. So hang on to that for a second while I erase this. Recursively defined sequence. So it's still sequence. We're going to take a term they give us, say the first term, and you use it to find the next one. And then after you find the second term, you take the second term to find the third term, and so on. Okay, so recursively defined sequence just means they give you the first term or you have to find it, and then you take the first term, plug it into the formula to find the second term, plug the second term in to find the third term, and you just keep going. The previous term helps you find the term you're looking for. Okay, so example 2 says the terms of the recursively defined sequence D sub n, where D1 where D1 equals 25 and D with the subscript of n plus 1 equals D subscript n minus 5. So here's what I'm talking about. You take the term that you already have, or the first one, and you plug it into the formula to find the next one. That's what this is telling you. So we were given the first term of 25. We're going to plug it in here to find the second term. Okay, so D1 is 25. D2, we're going to take 25 minus 5, which is 20. Okay, so now we're going to take D2, which is 20, and plug it in to find D3. So 20 minus 5 is 15. And then we're going to do one more just for fun. So since D3 was 15, D4 would be 15 minus 5, which is 10. So this recursively defined sequence, its terms are 25, 20, 15, 10, and it keeps going. Okay. So we're going to do some practice problems to help you get ready for your Google form for the day. Alright, so we're going to find the first 5 terms of these sequences, but on your Google form I just asked for the first 3. Okay, so find the next 5 terms, or the first 5 terms of this sequence. AN equals negative 2/3 to the n power. So if you're working with your phone calculator, which that might be your situation, I'm going to teach you how to use it to find these answers. Okay, so obviously the first one's not too bad, because if you plug in 1 right there, anything to the first power is just itself. So this A1 is negative 2/3. Okay, now, if you want to use your noggin and figure it out that way, that's fine too. I'll show you that as well. But negative 2 squared, so negative 2 times negative 2 is 4. And 3 squared is 9. But if you didn't want to use your brain for that on your phone, you could do 2/3 negative. So 2 divided by 3, and then you make it negative, equals this decimal, obviously. And then you would hit the squared button, and it would give you the decimal form. So on your Google form, I put either the fractions or the decimals, depending on how you figure it out. Okay, so 0.4 repeating is the same as 4/9. So like that. Okay, now the third one, third term, negative 2/3 to the third power. Okay, negative 2 to the third power is negative 8. And then 3 to the third power is 27. And if you were to do this on your phone calculator, like I said before, 2 divided by 3, and you make it negative, then you would hit the x to the third button, and you would get this funky decimal. Here, let me turn it better. Which is negative 0.296296, blah, blah, blah. Okay, and if you were to check that out, negative 8 divided by 27 is that same thing, negative 0.296296, blah, blah, blah. Okay, so you can do it either way, whatever works best for you. If you like a bit of a challenge, you can just do it with your brain. Or you could do negative 2 to the 4th, get that number, then 3 to the 4th, get that number, and write it as the fraction. We'll do that once just for fun. Okay, so negative 2, and then you'll have to press the XY button on your calculator, to the 4th is 16. Okay, then 3, XY button, 4 is 81. So that's 16 over 81. Alright, and then A5, negative 2/3 to the 5th power was negative 32 over 243. So as you can see, as this sequence gets higher in power, the bottom number gets bigger a lot, very quickly. Okay, and that's what happens when you have exponential functions anyways. This is an exponent, so exponential function, they get carried away pretty quickly. Alright, so now we're going to do part B. Alright, part B, we have the sequence is 5 minus 1 over n plus 1 over n squared. Okay, so A1 is 5 minus 1 over 1 plus 1 over 1. So 5 minus 1 is 4, 4 plus 1 is 5. Okay, 5 minus 1/2 plus 1 over 4, because we have to square n for that last part. Okay, so if you want to do that on your calculator here, 5 minus 1 divided by 2 equals, should be 4.5 at this point, plus 1 divided by 4 equals 4.75. Okay, 4.75. Alright. Okay, A3. 5 minus 1 over 3 plus 1 over 9. Okay, so let's try that. 5 minus 1 divided by 3 equals plus 1 divided by 9 equals 4.7 repeating. So 4.7 repeating. Alright. A 5 minus 1/4 plus 1 over 16 equals 4.8125. And if you want to do that on your own time to make sure you get that right, then that's fine. I'm just telling you what they are because I think you get the point at this point. But a 5 would be 5 minus 1/5 plus 1 over 25. And that number was 4.84. Okay? Alright, so on your part of the Google form, you will just have to find the first 3 terms, not 5. And I put both the fraction answer and the decimal answer as possible answers. Alright, so we've got one more practice problem, and then it'll be up to you to do your homework for the day. But like always, I'll be there to help you if you need help. Just send me a message and I'll be there. Alright, so on number 2, we have to write the next 2 apparent terms. So I'm going to give you a list of numbers. You have to figure out the pattern and then tell me the next 2 numbers. And then we're going to describe what kind of pattern we saw. Okay? But on your homework, you just have to tell me the next 2 numbers. Okay, so we have 3, 7, 11, 15. Alright, so what do you think we're doing here each time to get the next number? Okay, I think we're adding 4 each time. So if we're adding 4 each time, the next 2 numbers would be 19 and 23. And we are adding 4. Okay, so that's it. Now this next one gets a little tricky. We have 1, negative 1/2, 1/4, negative 1/8, ... Okay, so you can see it's alternating between positive and negative, and it looks like the bottom of the fraction is being like multiples of 2. Not the first one necessarily, because that's just a 1. But then we have 2, 4, 8. So I think the next one's probably 16 on the bottom, and then the next one on the bottom is probably 32. And if we alternate between positive and negative, we'll have 1/16 and negative 1 over 32. So the way you would describe that, you could just tell me in words what you see happening there. But this is the actual sequence formula, the equation, what you did to get the next number. Because if you started with 1 right here, anything to the 0 power is 1. So that's how the first term happened to be 1. And then you plug in a 2 here. So 2 minus 1 is 1. And then negative 2 to the first would be negative 2. And that would give us the negative 1/2. Math. Okay, so like I said, if you need any help, I'm here for you. I think you're all doing great so far. Keep up the good work. And tomorrow we'll continue talking about sequences. So, bye.